So now let's talk about the load carrying capacity. So, what are their possible strategies? So let's take the first case. Suppose we have uncoated component and we have load when one body is contact with the other one. So this is one body and this is the other body which is in contact with a component. So this one is uncoated. So stress distribution on the substrate surface looks something like in this fashion. So this is the stress distribution on our substrate surface. So this is the typical situation when one body is in contact with the other one with no formal coating, which is the worst condition. And we apply the normal stress. As we discussed, we have maximum shear stress at the given depth. Now moving forward, now if we have thick hard coating, this is our component, and on top of that we have a thick hard coating. So this is a thick hard coating. And we are going to apply some load as in previous case. Here we have elastic load spreading in this region, and the stress distribution on substrate surface looks something like in this fashion. So this is the stress distribution on the substrate surface. So if we can apply a coating sufficiently thick to host this maximum shear stress, actually we increase the strength of our object. So our material can counteract the plastic deformation of our stress components, and we have an excellent load bearing capacity. So the main problem is to produce so thick hard layer. So this is not definitely a PVD coating as we said, but it would be a hard layer produced by thermochemical treatment like night fighting or carburizing. In this case, the typical depth is the order of 100 micrometers, but unfortunately, these layers are not able to provide wear resistance to hard coatings like nitride and carbide. Now let's discuss about the other scenarios. Now suppose we have scenario like this, and this is our coating. And here is our applied load. So this is basically, the coating is basically of thin high modulus coating. So this stress distribution in this case looks something like this thing. So this is the stress distribution on the substrate surface if we have thin high modulus coating. So this is the other alternative option, that is to deposit a thin layer with a very high elastic modulus in order to support the high fraction of the applied load. But again, if we analyze the maximum load, it is tolerated by this configuration. We find this load increases as the thickness of the coating increases. So then in order to have significant improvement, we have to increase the thickness again. We have this intrinsic limitation. Now, if we use the last configuration, that is by using thin shaft coating, this is our component. And this is our thin shaft coating. Thin soft coating, and for this we are going to get the stress distribution on substrate surface in this fashion. This is the stress distribution. On this substrate surface. For thin soft coating. So this is the third approach, or basically we can say last approach to the previous one. In this case, we apply a soft coating, which is a highly deformable, and when we apply a normal load, we can generate a high contact area by deformation of this layer, and then we generate a lower average stress. It is a very effective approach for load bearing capacity. Of course, the negative effect is a limited wear resistance of this soft coating, and we cannot expect a maximum wear resistance if we follow this approach.